we're on to a section that I really enjoy because a lot of times students will ask me, when do we use this? Is this real world stuff? This is a good example of a really good real world set of problems that we're going to learn. Now, before we start, there's a couple keywords that we want to identify. In math, and this is only in math type of stuff, if you see the keyword is, that means equal to, or an equal sign. If you see the word of, that means multiplication, or multiplication sign. And if you see what number or what percent, or even the word what, that's usually going to be a variable, something like an x. Okay, for this section, I will use x for every variable, but you can use whatever you want. I just like using x's because I like being consistent. Okay, so when we're working on these problems, we'll be given a sentence. 43% of 111 is what number? In order to solve this problem, the first thing we have to do is identify the key words that we had from earlier. The first one I see here is of. The second one I see is. And the third I see is what number. Now, using what we learned earlier, we can create a mathematical sentence. So of is a multiplication sign, is an equal sign, and what number is x. Now we can take the numbers that we saw earlier and bring them down. 111. Always want to turn percents to decimals if we get a chance. So this is 0.43. And all of a sudden, we now have an equation that we've been working with for the last couple weeks. In this situation, though, the x is already by itself. So to solve for x, we just have to turn this into a number, 0.43 times 111, which gives us 47.73. So we go x equals 47.73. In order to solve this problem, or to make sure we solved it correctly, I'm going to reread the sentence, but changing the x for the number, or substitution. So the sentence now reads, 43% of 111 is 47.73. And that makes sense to me because 43% of 111 should be a little bit under half, because we know 50% is under half. This number looks to be just under half of that one. So it looks like a realistic answer. Down here on the bottom, same type of problem. Let's identify the key words. Here we have is, here we have of, and here we have what number. Is equal to, of is multiplication, what number is x. This stays the same. This turns into a decimal, and we have our equation. Now the problem we have, so if we draw the line down the equal sign, the x is not by itself anymore. So to get rid of this 0.83, we're going to have to divide by 0.83 because it's being multiplied by x. We have to do the same thing to both sides. And now the x is by itself, but we have to figure out what this is. So x equals 162 divided by 0.83, which is 195.18. Okay, to check our answer, we're going to reread the sentence to see if it makes sense. 162 is 83% of 195.18. Well, 195.18 times 83% should make that number a little bit smaller, but not a lot, so this one seems realistic as well. Now, an example of a problem that wouldn't be realistic would be something like this. 83 is... let's go 50% of 40. And in this one, that doesn't make sense because 50% of 40 would make that number smaller, and 83 would have to be bigger. So this is an example of a problem that doesn't work. Our two examples are problems that do work. I'd like you to try these two on your own. Be careful on the bottom because it has the keyword percent. Okay, keywords. Times equal to x. 0.47 times 47 is what number? This time we just have to multiply, which is 22.09. Okay, that was one of the easier type. This one here at the bottom is a little bit trickier. What percent of 150 is 84? Well, this is x times 150 equal to 84. Now we have to divide by 150 on both sides. So x equals, and here's where it gets a tiny bit trickier, so you got to be a little careful here. Whoops. There we go. 0.56. And I hope you went back and looked at the problem and said what percent. So this is equal to 56%. And that is our answer for that one. Okay, if you have questions on those, make sure you ask me. But they will all work out the same way. You may just have to solve them a little bit at the end. Let's try, oh, we've already done those. We've already done those as well. Okay, Mount Churchill in Alaska is 15,638 feet high. The height of Mount McKinley is 130% of the height of Mount Churchill. What is the height of Mount McKinley? For this one, whoops, don't do that. We have to find the key information and then create a sentence ourselves. So when I go through this, the key word is here. Mount Churchill of Alaska is that high. Mount McKinley is 130% of the height of Mount Churchill. So it sounds like our sentence. Mount McKinley is what we're trying to figure out. So this is going to be our x. That equals 130% of the height, so times the height of Mount Churchill, which is right there, 15,638 feet. So now we have our sentence created. We have to turn this to a decimal, but it works out just the same as all the others. This one, the x is already by itself, so we don't have to solve. We just have to type it into a calculator. 1 point, whoa, you know, sometimes I have no idea what I'm doing. All right, 1.3 times 15,638 feet, which is 20,329 about. We got to label it. And the big key with story problems, we got to ask ourselves, does this answer make sense? The big question here is which should be higher, Mount Churchill or Mount McKinley? And from reading the sentence, Mount McKinley should be higher, which is what we found. Therefore, our answer is correct. A king cobra can reach a length of 18 feet. However, the world's largest snake was 60% larger than this. How large was the largest snake in the world? So, keyword is 18 feet and 60% larger. Okay, so there's a couple ways to solve this. We know that a king cobra is 18 feet, and so the world's largest snake was 60% larger. So I know that 60% larger than something is equal to 160% of that thing. Now, if you just wanted to multiply 18 times 60% and then add it on at the end, that's also correct, but I'm going to do it this way because it's similar to what we've been doing. So 18 feet is equal to 1.6 times, whoops, no, that's not right. It's 18 times 1.6 equals our x. Now, if you did it the way I did right away, 18 equals 1.6 times x. That means we would have divided. So I would have 18 divided by 1.6. That would have given me 11.25, and I should understand that's not correct because the king cobra is not the largest snake in the world. So if you think about your answers, sometimes you can get some good ones. So 18 times 1.6 gives me 28.8 feet. Or I could have done 18 times 0.6, 10.8, and I could have added it plus the 18, and that would also give me 28.8 feet. Okay? A lot of these are you just trial and error. Try them, see if your answer makes sense, and then go from there. Last one, I promise. An ancient shark called the Carcalor, I don't know how to pronounce it, but I do know it's Megalodon, which is what I'm going to call it for the rest of the problem. Megalodon had 7.25 inches on his teeth. That's how long his teeth were. This is 240% of the length of a great white shark's teeth. How long are a great white? Try this on your own, see what you get. So the key sentence is here. So this is referring to 7.25 is equal to 2.4 times x. Whoop, that should be 2.4. 2.4 times x. Well, I got to divide. So x equals 7.25 divided by 2.4, which is 3 inches about. Okay, so I want to put this in perspective. This Megalodon was a giant shark from when like dinosaurs were around. Okay, its teeth were over twice as long as a great white shark, which is terrifying, as you can see from the picture. So that's pretty massive, and I'm glad that those things aren't around anymore. Okay, so this is a long video. The next couple won't be nearly as long. All right, assignments posted on the website.